topic is IUPAC nomenclature of coordination compounds. IUPAC nomenclature of coordination compounds. Very important topic for all competitive examinations, including board exams. IUPAC nomenclature of coordination compounds. So here we will discuss about the rules to write the name of the coordination compound and some examples. How the examples means? First, let me take the structure. For that, let you write the name. Then, let you take the name. For that, let you write the structure. So, topic IUPAC nomenclature of coordination compounds. So, first, the rules to write the name of coordination compounds is, the first rule is to write the name of coordination compound. IUPAC organization, that is International Union of Pure and Applied Chemistry organization, proposes some rules to write the name of coordination compound. In that, the first rule is we have to say cation name first. Whether it is simple ion or complex ion, we have to name cation name first. Let me write in shortcuts cation name first. Then we have to write anion name. This is the first rule you have to know. Whether it is simple cation or complex cation, simple anion or complex anion, both are complex, means cation and anion both are complex. First you have to say the name of cation first and then anion. Suppose if cation is complex, then we have to follow next rule. The next rule is ligand names first. If the ion is complex, whether it is cation complex or anion complex, to say the name of the complex ion, first we have to say ligand names. There are different types of ligands are there. They have certain unique names for some ligands, then some have common names. So how to write the ligand names in the second rule? Let you write. So once again I am saying in the second rule, whether the complex ion is cation or anion, first we have to say ligand name and then central metal ion name. First ligand names first and then central metal ion name. Central metal ion. First you have to say the ligands. Ligands have certain names. Some ligands have unique names. Some ligands have common names. There are some rules are there to write the ligand names. What are the rules in that? First let me write. If ligand is negative, compulsory they have suffix as what? Suffix definitely they contains ide or ite or is ide or ite or ate, like that. Anions contains suffix like this. Common. This is common name. Just generally, if the ligand is negative, the suffix for that ligands will be there as ide, ate, like that. For that, to write the name of the ligand in complexes, complexes. How we have to write the name of that negative ligands means I becomes I2. I becomes I2. At the place of E, we have to write O. 8 becomes A2. Like that, we have to write the negative ligands in the complexes. If ligand is negative, compulsory, the suffix has to write as what? If id is there, I2. If it is there, I2. If 8 is there, A2. Let us see some examples. Suppose Cl minus is there. Generally, what is the name of this ion? Chloride. I suffix is there for this. In the complexes, to write the name of the ligand, if Cl is the ligand, Cl minus ion is the ligand, you have to write as what? Chloride. In some books, old name, 1992 rules, we have it as chloro. But in 2003, IUPAC organization proposed some modifications for anion ligands. That modification says we have to write as what? Chlorido. Of course, we can also write it as what? Chloro. It is also correct, but mostly we have to write it as what? Chlorido. Chloro name also correct. Acceptable. But both are there in the options in the examination paper. If chlorido is there, chloro is there, we have to mention chlorido. We should not choose the option chloro. This is the first thing. Next, for ith example, suppose NO2 minus is there. Generally, its name is what? Nitrite ion is. So in the name of complexes, when it acting as a ligand, you have to write this as what? Nitrito, not nitro. We have to write it as what? Nitrito. And another one. If NO3 minus, if it is there, generally the name of this anion is what? Nitrate. So in the complexes, if NO3 minus is a ligand, you have to write the name as what? Nitrato. Like that. Negative ligands, if it is there as the ligands in the complexes, we have to write like this. This is A rule in the second. If ligand is positive, if the ligand is positive ligand, if it is present, for that compulsory we have to write the suffix as what? IUM. Compulsory it should be there as IUM. Example, NO plus if it is there as the ligand, NO plus. Only NO is there, nitrosyl. If NO plus is there, it is called what? Nitrosinium. Nitrosilium. Nitrosilium because first change. And if NH3 plus if it is there, ammonium. It is ammonium. You have to write like this. And some neutral ligands have special names. Special ligands. Some neutral ligands have special names. What are that? Generally, NH3 is there. Generally, it is what? Ammonia. But in the complexes, we have to name it as what? Amine. Double M. If H2O is there, we have to call it as what? Aqua. So like this, we have to write the names of the ligands. This is the second one. write the name of the ligands, we have to follow these rules. After that, the third rule is, next I am saying third rule. After saying this rule, let's go for the examples, because first you should know these rules. After that, the third rule is, after writing central metal ion, its oxidation state must be in Roman numbers. So, after writing central metal ion, first in the complex ion, first we write the ligand names, then central metal ion name. After writing central metal ion name, compulsory you have to mention oxidation state in Roman number. It is rule. Let's write some examples of that. Compulsory oxidation state should be there. And number 4, if complex ion is anion, central metal ion contains suffix 8. Compulsory it should be 8 if complex is anion. If complex is anion, cation, no need to write 8 suffix for central metal ion. As it is name, whatever the name is there for central metal ion, that we can write. But if complex is anion, negatively charged ion, compulsory we have to write central metal ion suffix 8. This is. And next, addition, it is not the rule. Next thing is not the rule, but you should know the type of complexes. This is the third rule, this is the fourth rule. After that, I am saying some complexes. Generally, on the basis of the ligands present in the complex, on the basis of ligands present in the complex, the complexes are 2 types. On the basis of ligands present in the complexes are 2 types. One is homoleptic complexes. Second one, heteroleptic complexes. Homoleptic complexes, heteroleptic complexes, based on the ligands present in the complex. Homoleptic complexes means what? Homoleptic complexes contains only one type of ligands. They contains only one type of ligands. Homoleptic complexes contains only one type. Heteroleptic complexes means these contains, heteroleptic complexes contains more than one type of ligands. Maybe 2, 3, 4 types, depending upon the complex. So heteroleptic complexes means they contain more than one type of ligands. Homoleptic complexes means they contain only one type of ligands. If the complex has single type, same type of ligands, we call that as homoleptic complexes. If they have more than one type of ligands, we have to call it as heteroleptic complexes. So in homoleptic complexes, the number of ligands will be mentioned as, for single, mono, for 2, di, for 3, tri, for 4, tetra, like that. The number of ligands are mentioned. Number of ligands mentioned as, for 1, we have written as what? Mono. For 2, we will write as what? Di. And for 3, if 3 ligands are there, we will write as what? Tri. For 4 ligands, if 4 ligands are present, we will write it as what? Tetra. 5 ligands if it is there, we will say it as penta. 6 ligands are there, hexa. 7 hepta. 8 octa. So like that we will write. For only one type of ligands it is present in the complex, the number of ligands in the complex can be mentioned. If only one ligand is there, it has mono. If 2 ligands is there, it has di. Suppose 2 chlorides are there, dichlorido. If 3 chlorines are there, chlorides are there, trichlorido, tetrachlorido, pentachlorido, like that. That is for homoleptic complexes. In case of heteroleptic complexes, if ligands are more than one type, how we have to write the names? How we have to write the names? Please see. In heteroleptic complexes, the ligand names has to write based on their alphabets. If more than one ligands are present in the complex, we call that complex as heteroleptic complex. In that type of complexes, we have to write the ligands names based on their alphabets. I will write examples for that. This is so. And fifth rule, this is not rule, this type of complex, that's why I didn't write the number for that. Now fifth rule, according to IUPAC, if ligand contain number as the name, if ligand has number like ethylene diamine, triethylene triamine, ETA, ethylene diamine tetraacetate, like that. If ligand has number in its name, in the name itself, if number is there, the number of such ligands, the number of such ligands are mentioned as for di, for 2 ligands, if 2 ligands are there, we have to write as what? Bis. If 3 ligands are there, we have to say it as tris. If 4 ligands are there, we have to say it as tetrakis. And if 5 ligands are there, we have to say it as pentakis. Like this. So if only ligands are there, there are no number in the names for the number of ligands, we have to write as what? Mono, di, tri, tetra, penta. But if the ligand itself, the number is there in the name, compulsory such ligands number can be mentioned as for 2 ligands base, for 3 ligands tris, for 4 ligands tetrakis, for 5 ligands pentakis, like that you are right. These are the rules, 5th rule in IUPAC. So this is some basic rules to write the nomenclature. Then let me go for examples. So based on the examples, let me write some more rules, because all the rules at a time without the examples means it's a waste of time. Let me take examples and let me write the names. There if we get any new things, there let me write the rule. Okay, like that it will be. I am suggesting all of you in the NCERT textbook, lesson backside, unsolved problems will be there. He has given very nice examples to practice IUPAC nomenclature. In some questions, he has given structures. For that, we have write the names. For some questions, he has given names. For that, we have write the structures. First, let me see the writing of name for the structures. They will give the structure. For that, let me write the name. The first step, they will give the structure, and we have to write the name. Examples of complex compounds. To write the nomenclature, I am saying. They will give the structure, we have to say the name. Some cases, they will say the name, they will give the name, we have to write the structure, we have to identify the structure. First, structure to name. Suppose CONS3 6Cl3 he has given and asking name. Simple example, that's why I am taking this stuff. First, what is the first rule? You have to say the cation name first, after that anion. Means first you have to identify what is cation here, simple or complex. If you hydrolyze this one, if you ionize this one, you will get +3 complex cation -1 Cl minus 3 Cl minus we get. So here the complex is cation. Cation is complex. So first we have to write the name of the complex. If you write the name of the complex, first you have to say ligands. First you have to say ligands. And there also you have to identify, is it homoleptic or heteroleptic. Homoleptic means what? Only one type of ligands is present in that. We call it as what? Homoleptic. Here only 6 ammonia molecules, only one type of ligands are there. So it is homoleptic complex. 6 ammonia molecules are the ligands. They are only one type. That's why homoleptic complex. 6 are there. So we have to write its name as what? Hexa. NS3, it has special name. Already I wrote that one. What is that special name? Amine. Amine. After that, ligands completed. After that, sentimental ion. What is the sentimental here? Cobalt. After writing sentimental ion, next rule in the IUPAC is oxidation state in Roman number. You have to write in parentheses. Its oxidation state. In the one video, I have given how to calculate oxidation state. Please see that one. So here, its oxidation state is +3. So Roman number I wrote in 3. Complex cation is completed. After that, anion. How many anions are there? 3. But don't write trichloride. Just write down it as what? Chloride. No need to mention the number of anions. So this is the name of hexaamine cobalt 3 chloride. One example. He has given structure. I wrote name. Let me take one more example. What is that? CrH2O4 Cl2 minus. CrH2O4 Cl2 minus. This is first example. This is second example. Once again, he has given structure. We have to write the name. Rule: cation anion identification. First rule. Here, anion itself, there is no neutral molecule. There is no cation, direct anion because minus charges. Whole complex has minus charges, so it is anion. Let me write. It is complex. If it is complex, first you have to say ligands. What are the ligands of present? Water is ligand as well as chloride also ligand. If more than one type of ligands are there, we have to call that complex as what? Heteroleptic complex. So it is heteroleptic complex. If heteroleptic complex is there, we have to assign the ligands based on their alphabets. I wrote that. The ligands, more than one type of ligands are there in the complex. We have to write the name based on their alphabets. So H2O name is aqua. Cl minus is there. Its name is what? Chlorido. Which one will come first? Aqua. C. A. C. A will come first. So we have to mention first this one. After that, chloride. How many are there? 4 are there. So first, tetra. 4. In the name there is no number, so no need to write it as tetrakis. Just aqua, just simple name is there. There is no number in the name. So tetra. Aqua. Tetraqua. 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 After that, dichlorido. because two chlorides are there, chlorides are there, dichlorido, ligands mentioned completed. Then chromium. No, it is negative ion. Complex is negative, no? So if complex is negative, simple metal ion always end with the suffix what? 8. Chromate. Chromate. It's oxidation state. If you know, directly you can, or if you want to calculate, you can calculate. CRX, they divide as x plus 4 into 0 plus 2 into minus 1 equal to minus 1. What is x value? It is 0, minus 2, minus 1. So it goes to that side. So oxidation state becomes total charge is minus 3. So x value becomes what? Equal to minus 3 is enough. Let me calculate that x value here. So x plus 0 minus 2 equal to minus 1. X equal to plus 1. This is minus only, na? No. It is plus. It is not minus. Sorry, I choose the wrong one. It is plus. So if it is plus, directly we have write as what? Chromium. If it is minus, we have write as what? Chromate. So here it is plus. So it is chromium. Chromium. Its oxidation state. If it is plus 1, then it becomes what? Plus 3. So oxidation state plus 3. What it means chromium plus 1 very rare condition. That's why it cannot be minus. So there it is, mistake there. So that's why it is. If it is plus, no need to write down directly chlorido. It is first tetraqua dichlorido chromium 3 cation or ion, because total it has charge. So like that you have to write the name if structure is there. And one more third example. Let me take third example for third example. K4 FeCN 6 times. Another example. First rule, cation is potassium. We have to write the name as it is, because whether it is simple or complex, first we have to mention cation name. So I wrote potassium. After that, anion is complex. If complex is there first, then we have to write ligand names. How many ligands are there? 6 are there. So the exam Cn minus, in this case Cn minus. Cn minus means cyanido, because it is cyanide. We have to write as what? Cyanido. So exam cyanido. Iron is there, but suffix 8 should be there because anion complex. So ferrate, and its oxidation state plus 2. If you have, you will get that one. This is the name. Potassium hexacyanidoferrate. In some options, suppose if the question paper has given this 93 rules, cyanido is not there, cyano is there, that is also correct. That is also correct. If both are there in the options, cyanido is there, cyano is there, but choose cyanido. You should not choose cyano. So like this, you have to write. So this is structures given, we wrote name. Then, if names are there, how to write the structure? If names are there, how to write the structure? Please. Writing of structures. If names are there, how to write structures? Next type of examples, they will mention the name, we have to write the structure. Name to structure. Before examples, what we have seen, they have given structures, we wrote names. Now, they will give the name, we have to write the structure. Let me take one example. I will explain 2 examples for this, because lack of time. Alright. Potassium dichlorido dioxalato cobaltate. Potassium dichlorido dioxalato cobaltate, and oxidation state also has given, that is 3. Right. This is the name. Let's write the structure. Same I'm saying. Name given, let's write the structure. Before example, what we wrote? Structure given, name. Right. Potassium dichloride dioxalate cobaltate. First, you have to identify what is anion, what is cation. Cobaltate, 8 suffix is there, means compulsory complex is anion. So potassium K is cation. After that, dichloride means 2 chlorines. Dioxalate C2O4 taken twice. Oxalate formula is C2O4 2 minus. Dichloride first, dichloride this one. Dioxalate this one. Cobaltate, cobalt. So this is complex. Then how many potassiums are there? Number of potassiums depends upon the charge. This is very important. Number of potassiums. Just KCl2 C2O4 taken by CO is not correct. So first you have to calculate the charge of complex. If you calculate the charge of complex, automatically you can write the number of potassiums. Potassium always exists as what? Plus 1. So what is the charge of complex? Let me write. Charge of complex I am calculating. How to calculate charge of complex? That is also important. Sometimes he may ask directly charge of complex. He is mentioned it as what? X minus. What is X value he may ask? So please listen. How to calculate charge? Based on the charge you write potassiums. So if the name is given, writing of structure is little bit difficult. Reason is this. So now, how we are write? So in this complex, 2 chlorines are there. Its charge is always minus 1. Less 2 oxalates are there. Its charge is always minus 2. C2O4 2 minus. In this complex, Cl minus, C2O4 2 minus are the ligands. Oxalate and chloride. So 2 into minus 1, 2 into minus 2 plus, we don't know, sorry, oxidation state he has given as what? Plus 3. Oxidation state equal to X minus X. Okay, so let me calculate that. Minus 2 minus 4 plus 3 equal to X minus 6 plus 3 means X equal to minus 3. Minus 2 minus 4 plus 3 X. We don't know what is minus or plus. So minus 3 means here the charge is what? Minus 3. If X is there, that X is 3. So if minus 3 is there, potassium plus 1, there should be K. So this is the complex. Once again I am saying potassium dichloride dioxalate cobaltate he has given. So once again I am writing how we have to write it. Potassium K I wrote, its oxidation state is plus 1, charge is plus 1. Then dichloride 2 chlorines I wrote, dioxalate C2O4 taken twice I wrote, cobaltate, cobalt is a simple ion I wrote. Okay. So after that, plus 3 oxidation state. So then how many K's are there here? The number of K's depends upon the charge of this ion. So first you have to calculate the charge. What are the ligands? These are the ligands. How you have to calculate charge? This is the rule. This is the procedure to calculate the charge. I got minus. So K. This is complex. Let me check the count. Yes, K3, CO, C2O4 taken to Cl2. If I write correct structure for that, K3, the options you will mention like this. C2O4 taken twice Cl2. This is correct structure. You can write like this also. Like this also. Okay, so this is if name is given, you have to write the structure. Let me try one more structure. This is one example I wrote. Let me write second example. Let me try. If anybody doubt, please try to write down that one. I'm taking one more example. Tetraamine platinum 3. Tetraamine platinum 3. Oxidation state 3. Platinum 3. Tetraamine platinum 3. Tetrachlorocuprate. Tetrachlorocuprate. And its oxidation state of copper is given as tetrachloride. This is the name he has given. Then write the number. How we have played the structure for us. Same procedure. Whatever the procedure we have used here, then we write the procedure. Name he has given, you have played the structure. It is little bit typical. Once again, I am saying, if the structure is given, writing of name is easy. But if the name is given, writing of structure is little bit tough. So, I understood. Shall I remove? Right. So, let's write the structure from this. Second example. The name is here. The structure, let me write. First, cation is platinum. Platinum directly they have mentioned. So, I am considering it is cation. Cuprate, copper complex is anion. Platinum complex is cation. Copper complex is anion. So, first let me write platinum. Pt. Amine means NS3. How many are there? 4 are there. So this is cation. Number let me write later. How many are there? Then anion, copper. What are they? Tetrachloride, Cl4. Or let me write CuCl4. Right. This is structure. But this is not correct structure. Number should be mentioned. Number of cations, number of anions in this complex must be satisfied. Charge balance should be there, but here charge is not balanced. Let's check balance or not. So its charge of cation, if we calculate platinum, how much he has given? 3 plus 4 ligands are there, 0 equal to x. So x value here we got as what? Plus 3, means its charge is plus 3. This complex charge, cation complex charge is plus 3. How means platinum oxidation state 3 as given. This is 3. I wrote as it is. Ammonia is neutral ligand, so 0. There are 4 ammonias. 4 into 0 is 0. So x equal to x plus 3. And for this copper oxidation state has given as 2. So I wrote it as 2. 4 chlorides are there, its charge is -1 because chlorine charge is -1 equal to x. After that nothing is there, so right. Then 2 minus 4 equal to x. Oxidation state here charge is what? -2. X value we got as what? -2 minus 4 na? So -2. Cation charge is plus 3, anion charge is -2. So 1 is not correct. Then what you have to do? You have to multiply this with 2. You have to multiply this with 3 to make charge balance. So after that, it becomes what now? Platinum NS3 4 taken twice, copper Cl4 taken thrice. This is complex. This is correct complex. This is wrong. If I write it as only this thing, if I write it is wrong. Its charge is plus 3, its charge is -2. To make charge balance, I am multiplying this with 2, I am multiplying this with 3. Take it twice. Let me check. Let me check. What is that? Tetraamine CuCl4. This is if plus 3 is. If plus 2 is there, only 1 must be there. So this is the nomenclature. If name is given, you have tried to structure like this. If structure is given, name not right. If structure is given, writing of name is easy, identifying of name is easy, but if the name is there, identifying structure is a little bit tough. It takes time. So, but you can try, you can practice by taking some more examples. Please practice. If you are not getting, write down in the comment. I'll explain with that. Okay. So this is, and one more rule is there. Last rule in the nomenclature. This is extra. Mostly the question will not be come from this, but we cannot expect it is not coming in the competitive examinations. That's why. Polynuclear complexes. Polynuclear complexes. If it is present, polynuclear complexes means what? Any complex more than one central metal ion, if it is there. Polynuclear complex means what? More than one central metal ion will be there. More than one central metal ion is there. Polynuclear complex means. So in that case, nomenclature will be little bit different. Little bit not different, just some additions are required in case of polynuclear complexes. Polynuclear complexes means they have more than one central metal ion. However, right, I'll write example. I'm directly taking example. I take example. I have that one. H2O taken 4 times. Fe, OH, OH, Fe, H2O taken 4 times, like this complexes. This is polynuclear complex. How I am saying it as polynuclear complex? SO4 taken twice, he has given. SO4 taken twice. This is polynuclear complex. How I am saying this polynuclear complex? This is central metal ion, this is more than one central metal ion are there in the complex. And they are linked by some bridge ligands. We call it as what? Bridge ligands. Bridge ligands. If bridge ligands are there, their names compulsory have the prefix mu. This is prefix. Bridge ligands must be assigned mu as the prefix. By mentioning mu, you are writing it. This is just addition for polynuclear complexes. Mu will be there if the ligand is bridge. Compulsory prefix should be there. So name is tetra aqua iron mu dihydroxo, because both are same. Mu dihydroxo. Yes. Tetra aqua. Tetra aqua iron. Its oxidation state is 3 as mentioned. You can calculate that one also. Mu dihydroxo. Hydroxido also you can write. Hydroxido. Once again, after that, tetra aqua iron. Once again, its oxidation state is 3. Sulfate, SO4 2 minus is there, na? SO4 taken twice is there, so sulfate. This is the name for polynuclear complex. Extra thing is what? Mu will be there for bridge ligands. Tetra aqua iron, its oxidation is +3. After that, bridge ligands, same ligands are there. If different ligands are there, separate mu you are right. I like it. Mu dihydroxo tetra aqua iron sulfate. Suppose at the place of OH, if NH2 is there, it is not mu hydroxide. It is amido hydroxo. First mu amido. Once again mu hydroxo. If more than one type of bridges. If only OH groups are there, mu dihydroxo. But here one OH is bridged, another NH2 is bridged. So in this case, alphabets first we have found amido hydroxo tetrahydroxide. So this is IUPAC nomenclature, rules, examples, etc. for complexes. Thank you.